Hey everyone, welcome to Hawks Tutoring. I hope you're having a great day. Today we are doing Chapter 3 Extended Response section, Question 10. This is the last chapter of the question, so we all should be excited. Or not, since this is the last question on the textbook, okay? So hopefully this video helps you solve this problem. And let's get into the question. Question 10. Points A, B, and C lie on a circle with center O and radius 1 as shown. So I've pretty much drawn the diagram, label a bit of the radius for you already, so it should all be here. And then part A says, give reasons why triangle ACD, so this triangle right here, AC to D, that right angle triangle, is similar to triangle AB and C. AB and C, that's also a right angle triangle, so that's already giving us some hints to how to show this, okay? So we need to show that triangle ACD is similar to triangle ABC. And when they say similar, it does not mean that the triangles have to be the same. They just have to have the same angles and the ratio of the sides are the same as well, okay? Or the ratio between the sides to be more specific. And just on a side note, guys, when you're dealing with similar triangles and they give you the side lengths already, so in this case, length AC would be similar to length AB, length CD would be similar to length BC, and length AD would be similar to length AC. So it's just the orientation wise. So if you want to find ratio, you can go, yes, AC divided by AB is equal to CD divided by BC and all that. But that's just year 11 stuff. You most likely won't need it, but who knows, right? Just an extra information for you. But let's get into the question. Triangle ACD, I will draw it right here. It is your right angle triangle. This is A, this is C, this is D. It's got the 90 degrees and it's got theta. And then triangle ABC, so this triangle right there, you might already be able to see it, but this is 90 degree, and ACB, this is theta. Well, it's pretty obvious that angle CDA is equal to angle ACB because that's a 90 degrees. So 90 degrees. And also that angle CAD, this angle right here, is the same as angle CAB because it's equals to theta. And if the two angles are this, obviously if you found the two angles, the last angle must be the same as well. So you can say, therefore, triangle ACD is indeed similar to triangle ABC. And you're done, okay? So that's how you show that two triangles are similar. Right, so let's move into part B next. So part B, give the coordinates of C in terms of circular functions applied to 2 theta. Well, we know that this 2 theta here is applied to this triangle. So I'll draw the triangles. You should be expecting a lot of triangles in this video. So yeah, we all love triangles in maths, okay? ODC right there, and the hypotenuse is 1 because that is the radius. And I'll make that look like an O. Right, so how would you find the coordinates of C? So what is this? Like, what's the x coordinate and what is the y coordinate? Well, it starts from the origin, guys. So if you want to find the x coordinate, it's just finding the length for OD. And if you want to find the y coordinate, it's just finding the length for CD, okay? It's as simple as that. So let's find the length of OD first. If you want to find the length of OD, let's use a little bit of trig to help us. Cos 2 theta is equals to OD divided by 1. So therefore, OD is equals to cos 2 theta. OD is equals to cos 2 theta, meaning the x coordinates for C is cos 2 theta. And if you want to find the CD, sine 2 theta, because that is opposite over hypotenuse, then that is just sine 2 theta equals CD over 1. Therefore, CD is indeed equals to sine 2 theta. And you're done pretty much. The x coordinates would be, so I'll write it right here, x coordinate cos 2 theta for point C, and the y coordinate is sine 2 theta. Okay, so C. Let's move into part C. What does part C say? Find CA in terms of theta. So we need to find this length. Don't worry, I'll draw more triangles. In terms of theta, so in terms of this right here. And then double I find CB, so this instead. In terms of theta, both of them using this triangle, A, B, and C. So let's draw that triangle down here. A, C and B. Okay, so that is B. This is theta, and the question asks, find CA and find CB. So find CA and find CB. Well, we need to fill in one more information, and if you look at our graph right here, A to B is pretty much 2 radius, right? Or it's pretty much your diameter. So the length from A to B, as you can see, is 1 plus 1. So A to B would be 2, and therefore we can start going through this question. Okay, so what is CA? If you want to find CA, guys, using trig again, this is the adjacent length. So cos theta equals to CA divided by hypotenuse 2. This is 90 degrees. I've got to label that. And if you want to find CA, that would be 2 multiplied by cos theta. And of course, if you want to find CB, which is part double I, that is sine theta, so opposite, so that would give us CB divided by hypotenuse, which is 2, and CB is therefore 2 sine theta. Okay, so that is part C, I and double I. Let's go into part D. I'll bring the picture down here, so I'll cut it quickly. Awesome, we got the picture. So I'll fill up in all the information first. We know that CA is equals to 2 cos theta, and we know that CB is equals to 2 sine theta. We also know that OD would be cos 2 theta, so that was the x coordinates, and we also know that CD is equals to sine 2 theta. Okay, so that was from part B and part C. Okay, let's do part D. Use the results of B and C to show that sine 2 theta equals to 2 sine theta cos theta. So that's actually a double angle formula. So we're essentially proving double angle right now. So to do this question, guys, I'll draw another triangle for you to see. This triangle right here, this beautiful triangles, more triangles, A, D, and C, 90 degree. We know AC or CA is 2 cos theta, and we know that CD is sine 2 theta. Okay, now the goal is to find or to show that sine 2 theta equals 2 sine theta cos theta. And to show that, guys, we're just going to use trig. It's as simple as that. Right, sine theta, so sine theta. So sine theta, we're going using this angle right here. Sine of that angle would be opposite over hypotenuse. The opposite is sine 2 theta. Imagine this as a length, okay? Don't think of it as anything else. Just think of it as a length. Divide by the hypotenuse, which is 2 cos theta. And guys, what you end up with, voila, is sine 2 theta equals to 2 sine theta cos theta. Whoops, the ink ran out for some weird reason, even though it's electronic. But that is part D, okay? So using this triangle. And we did use part B and C. See, this was part B and this was part C. Oh, this was part B actually, and that was part C. Right. So let's move into part E. Use the results of B and C to show that cos 2 theta is equals to 2 cos squared theta minus 1. So your double angle formula for cos. Right, we're going to do the same thing as what we did for part D, and that is to draw the same triangle right here, 90 degrees, C and D. This is A, this is theta, and we know that this is 2 cos theta. That is sine 2 theta, but we don't need that because we're proving the double angle formula for cos instead. But where are you going to get cos 2 theta? Well, that is from OD, okay? But we'll use that later. For now, let's find AD instead. So what is AD? Well, cos theta, cos of this angle, adjacent would be AD, and it's divided by hypotenuse, which is 2 cos theta. So that makes AD as 2 cos squared theta, because we're just going to bring this up to the left-hand side. Okay, now we know that AD is 2 cos squared theta. So from A to D right here, that would be 2 cos squared theta. Where do we get the double angle formula? So that is the cos 2 theta. Cos 2 theta is OD, okay? So OD is equals to cos 2 theta. There is actually another way of writing OD, and that is going AD, so 2 cos squared theta. So that is AD minus OA, okay? Now, what is OA? So AD is this length, OA is this length, the radius of the circle here. If you minus them together, minus OA from AD, then you actually get OD. So what is OA? OA is the radius, so that is 1, and you are done because OD is cos 2 theta, so therefore cos 2 theta is equals to 2 cos squared theta minus 1, and we've just proved it, okay? So QED, or as required, or whatever you want to put, smiley face, up to you, but that is this question all solved. Hopefully this video helps you guys for question 10. Aside from that, thanks for watching, and I'll see you in the next video.